Morning, everyone. It's 10 o'clock. We'll get started in just about 2 minutes, 1 minute, if I can get my screens going here
No, we're
in
starting.
less
Dang it.
time.
I'm
We're
on
starting.
camera. It's time.
You're the only one.
I have
All right,
tens of fans here. We're ready to go.
let's get going. All right. Come on, camera. There we are. So, good morning, everyone. Thank you for joining us. I am Alex with Sparkhound. If you are here to learn about the integration of Azure OpenAI with Copilot Studio, you're in the right place. This is what we're going to be talking about here today. We have a ton to get through, as I put in my little Q&A window today. So if you've been to Sparkhound events before, you know we like to be very conversational, keep it open and free flowing. We've got so much to get to today, but it's healthy. Trust me. We want to show you a lot of the information and the demos that Matt has cooked up for you. So please use the Q&A section for any questions that come up. We will stay as long as we need to, well into the night if we've got so many questions that you want to answer there. But that's how we'll be interacting with you today. If there are things that you want to talk about later, we'll put our contact information up as well, so you have that. But just know that that's how we're going to be talking with folks today. So without further ado, let's go ahead and get rolling. This is what we're talking about. So we're going to set the stage a little bit for why we're talking about Copilot agents and Copilot bots, right? Why that's important today. And Matt's going to talk about some of the prereqs you need to know if you're going to be building this out at your organization. And it starts with the RAG model. So we'll talk about what that means a little bit. Then we'll get into indexes and taking a look at some of our documents and the data points that we have and why that's important. And we've got some demos, and that's the real crux of the conversation today and what will hopefully be helpful for a lot of you here on the phone. We'll then talk about the integration with Copilot Studio and how we can put this all together with our low-code world and finish it up with some closing thoughts, then get to all of your exciting questions that you may have. Okay? Let's get rolling. So, who are we? My name's Alex Drozd. I'm the VP of Partnerships with Sparkhound. I'm based in Houston, Texas. I'm joined by my friend Matt. Matt, want to say hey?
Hey,
That works. He's the smart guy. He's got the demos. He's the technology guy. We've got you taken care of here today. So Sparkhound is a Baton Rouge, Louisiana-based Microsoft systems integrator, managed services partner in the world of Microsoft. We're really focused in three key areas. The modern workplace, so things like SharePoint Premium, Teams, Copilot for M365. We're really proficient in the low-code space as well. We've been doing Power Platform work since day one, as well as the Azure development world. So not just Azure DevOps and building custom apps in Azure, but Azure AI in the world of Azure OpenAI as well. We can help you out there. Okay? So enough about us, though. Let's get into the meat of the conversation.
no
We'll
more
talk about
sales
why.
stuff. No more.
No more fluff. We can talk to you about fluff later, but let's talk about why we're here and setting the table a little bit for why this is an important topic of conversation today. And I'll start with a little bit of a state of the union, state of the bot. We call these agents now state of the agents. If you
Microsoft
had
calls them.
attended
Microsoft
Ignite,
calls them agents.
they
Let's
do.
let's let's be
Well,
clear. Let's be clear.
keep up with the nomenclature, everybody. We're trying to as well. So at Ignite a couple weeks ago, if you were in attendance or you were there virtually, and you saw Satya's keynote, there were two things that he called out that I thought were pretty salient to today's conversation. He said, quote, "What Lean did for manufacturing, AI will do for knowledge work, which is increasing value and reducing waste." And he then said, "Every employee will have a co-pilot that knows them, their work, helping them unlock productivity, enhancing creativity, and saving time." And I thought those are really two key points. And I think something that, if you're here, probably relates to where you are in your organization today. Okay, maybe you all won't have a co-pilot. We're Microsoft partners, so we hope you have co-pilots. But the idea stands that we're all going to be working with Gen AI assistants. And we probably are doing this definitely in our personal lives, right? But maybe in our professional lives too, not just for asking about kind of calendar updates, but really kind of tangible things to help us in the workforce. And it's happening already, right? Customer service agents, in customer service, AI agents are handling 30% of interactions today. In manufacturing, AI agents are being used for predictive maintenance, and there's real tangible results there, right? Reduction in downtime is huge. And in 2020, Gartner said that only 10% of knowledge workers were using AI agents, and that in 2025, 50%. of knowledge workers will be using that. 2025, that's like what? 30 days away.
Couple days.
Couple days. So let that sit though, and we think to ourselves, okay, we're looking around the room here. Are 50% of our users really going to be using this in 30-ish days? And this is where, if you're like me, like I get a little leery with these stats sometimes, right? I'm kind of like, yeah, well, okay, prove it, right? And this brings to idea kind of meeting expectations with reality. And it comes to one of my favorite things. Who here is familiar with this chart, the Gartner hype cycle? Okay, I love
Good.
this because if not for anything else, the names are phenomenal. Like trough of disillusionment. I mean, come on, like that's incredible. Like slope of enlightenment is
Slope of
how
enlightenment.
I feel I'm living my life, whether it's on the upward or the downward. But anyways, that's a different topic of
I'm
conversation. But
always
the
on the
hype
slope of
cycle,
enlightenment.
yeah,
I'm skiing
the,
on it, or I'm climbing it. I'm pushing a rock up it.
this is it illustrates kind of the maturity and the adoption of different technologies over time. And we think about AI bots, right? When this first came out, we're thinking, wow, this is fantastic, a launch of a new technology. And then we hit a peak. And not only is Copilot everywhere, and there's different names of co-pilots, but you can't like watch a football game without like three-quarters of the commercials being about an AI something. And then we get to the trough of disillusionment where like not only am I sick of hearing about this, but like let's be real, how am I actually going to do this at my job when I've got so much else going on, right? And like everyone's asking me about AI and I don't have time to keep up. And then, over time we can reach a plateau. And plateau, I think, can have a negative connotation sometimes. But let's think about it like positively. Maybe you're not 50% there with your workforce, but what if you were 20, 25, like 30? And again, not just for nice to have items, but real things that are actually proving tangible results. Okay? Like what if we get there? That would really show some impact. And that's what we're here to talk to you about today. This isn't meant to be fluff about how great Copilot Studio of a product is, right? There's so many
It's
other
actually
webinars
it's actually kind of the opposite. We're going to be talking about the limitations and where you hit that wall,
yes.
hit that trough of disillusionment.
Yeah, we don't get invited out very much. But no, but realistically, we're here to talk about how this works, right? And because we're doing it and we're helping our customers do it and they're seeing it. And you can chat with your own data. Like actually, today, you can do this. You can build your own AI, find new streams via prompt engineering, right? So that's what we hope you can get from today is look, how do we do this, right? And how can I explain to my boss or my board where AI and where Copilot Studio and where bots that we can build are actually proving to be relevant today? So with that, I'll hand it over to Matt, and Matt will start with one of the most important things that we need to start when we talk about this, and that's the RAG model. Matt?
Yeah, we're going to talk about RAG. Guys, make liberal use of your React button so that I know that you're following along. I can't see you, so a lot of this I do is really about kind of reacting with everybody and seeing how they go. So make real use of that as we get going. Go ahead, Alex. So what is RAG? RAG is something that most generative AI programs are based off of. Now, we're not going to spend a whole lot of time on RAG. We're actually going to get really complex with it really quickly. So we're going to kind of blow through a lot of this. So RAG is retrieval augmented generation. And basically it means we're going to get the stuff, we're going to mess with the stuff, and then we're going to send something back to you. All right. A RAG part, the things that you need to build a RAG application are going to be an orchestrator. You're going to have something that's going to direct things where it is. So I get a message in. I'm going to send that message somewhere. I'm going to do something with it. I'm going to process the prompt. I'm going to take that whatever it is that I get from the user. I'm going to take my own system prompt or what I'm telling the AI is, and I'm going to mash those together as it goes over to the LLM. I need to get the data. So I need something that's going to either query or search my data so that my LLM has something to reason over. Finally, I have or not finally, I guess penultimately, if we're using big words, Alex was using big words earlier, so I'm going to use big words. So penultimately, we have our generative model, which is actually our LLM. That's the black box that we send stuff to and comes back. And then finally, we're going to do something with that stuff that comes back. I have to make sure that it's first of all, it's valid. And second of all, it's going to make sense to the user. All right. So that is what RAG is. And we're going to hit all of these pieces as we go. So typically you think RAG works like this. We have a user, he calls Copilot. Copilot goes ahead, or your LLM goes ahead, asks the data something, and then we get a response back, right? That's how it works. No, that's not at all how it works, all right? An actual RAG model looks something like this. You have your user, it's going to ask your LLM something, the orchestrator something. From there, your orchestrator is going to start to mess with that query. It's going to ask a large language model for the intent. It's going to go out and maybe process that with function or other pieces of code. Then it's going to then pre-process those other things that it's getting. It'll go to function apps, it'll go back to the LLM, it'll go to data. Finally, the retriever takes over and we grab some data, and then it comes back to the orchestrator, which then goes to the generative model, where we actually get our response and we send that to the user, right? There is a lot of stuff that goes on. Most of us, when we are building our copilots, we're thinking that first model, and you hit a wall really, really, really quickly. And so that's what we're going over today. How do we get from that simplistic model to this model? Okay. So the first thing you got to ask yourself is why do I want to do this? What possible reason could I want to step out of Copilot Studio or my low code method and get into OpenAI or some other system? A lot of times you have something in your data that's going to be pushing you beyond what Copilot Studio can do. Maybe you've got massive data sets. Copilot Studio, as it stands right now, doesn't really do great with really, really big data sets. Or you need more control over your data set. I need filtering. I need more context. I need something that's going to give me better answers. Or maybe you find Copilot Studio's functionality is limiting. You're trying to, everybody's done this. Like the third thing you do with Copilot Studio is you put in a bunch of SharePoint sites, and then you ask it a question, and it says, I don't know what you're talking about. So it's not returning generative answers as you expect, or your databases in knowledge, you're not getting good data sets, or you're not getting enough data, or you're just not getting any responses from your websites or other things. So most of the time we build out a front end, and then we need something to actually generate behind that. So that's one of the reasons why we would use this integration piece. So when you are using OpenAI, essentially, what does that mean? What does that mean for our application? Remember what we needed for RAG. We need an orchestrator, we need prompt processing, we need a retriever, we need that generative model, and we need some sort of post-processing. All right, my fingers here, jujitsu fingers, they're all messed up. So what does it mean? OpenAI is going to act as our retriever and our generative model. We're going to take that out of Copilot's hands, and we're going to handle that with OpenAI. Copilot still acts as our orchestrator. It acts as our prompt processor and our post-processing. When you're building this stuff from code, from scratch, it's these wiring pieces that take a lot of time. Copilot Studio gives us that out of the box, so it's if you're not completely off the reservation and trying to look for a fully coded model, this really saves you a lot of time.
So with that, then let's start talking about indexes, and specifically how our data is related to Azure AI search. Okay, this is another important thing that is really going to help you when you're building this all out. And we start thinking about the data types that we have available. This should be familiar to everybody here. You've got structured data, like your databases and spreadsheets, and you have your unstructured data, documents, blobs, chats, pictures, things like that. We're going to start talking about structured data, and we're going to start talking structured data because we're suggesting that's not the best place to start. If you're on this call and you haven't done this yet before, you probably shouldn't be starting with structured data. Why is that? Well, what is structured data? It's columnar data, right? Lookups and filters and understanding where things are in our databases, how best to use spreadsheets. If we want these bots to be for our users and we're building something up like a customer service bot, take me for example. I don't know how to find things in SQL, right? So if I'm trying to find things based off of that column lookup and filter, I'm not going to have the best experience doing this, right? And this brings up to mind the idea of LLM hallucination. If you've heard that before, that's what that means. We're trying to attack our search against a structured database, and it just isn't working very well, okay? natural language processing, large language models. As a business user, we want to type in how we normally think as humans, and that's how we want to get things back. Furthermore, if you really want to piss off your data scientists, like do this against a structured database and see what happens, because it's really going to degrade performance against that database if you're just trying to attack your structured data this way. Now, if you do want to get into some galaxy brain level 400 type stuff, there is a way to make this possible with graph databases. If you have large data sets, asterisk, because we can come back to this and talk about how that is possible. But again, if you're here, odds are you're just getting started for the first time. And where do we want to start? It's what we're most familiar with, and it's with our documents and with unstructured data. So, like, what is a document? Think about how you read an email. Think about how you read a book. There's an introduction, and then there's a conclusion. And in between, there are maybe bullet points that call out key concepts. And along the way, there are different kind of narratives that we're picking up on. But our LLMs out of the box like aren't going to know that. Okay, so if we just start throwing documents at it and it doesn't know how to read this document, it may draw the conclusion from the beginning of the document when the conclusion is at the end. Okay, think about this too. When we're using Copilot Studio just out the box, there are thresholds against your Dataverse limits where if you have large documents that you want to put through it, there's an 8 megabyte threshold. So let's say we have a very large document and we want to read some of the things towards the back end of it, like Copilot Studio out of the box is going to cut that off. And that won't be great for our search capabilities.
I want to note real quick that this 8 megabyte limit has changed, and it is continually changing, and it is getting better, but there is a limitation on it right now.
Well, yeah, exactly. That will change. But point being, like, if we want, our large documents to be used against this, like, how can we make that possible? And think about how we can break things up to make it more memorable. And that's called chunking. Okay, chunking takes into consideration how we search for things. If I'm searching against a product catalog for a men's large blue t-shirt that can ship tomorrow, right? If we think about how that breaks up into large t-shirt, blue, right? That's how we want to train our data to be involved as well. And what's great about Azure AI Search is we can do this in a number of different ways. We can do it semantically. We can do this by pages. If your page structure is very set, that we know how to train it against those page numbers, or token limits. If Azure capacity is a concern of you, you can set the chunking up that way as well. So the key term here is the search, okay? And how we're using this. And to Matt's point earlier, if you've used, Copilot for Microsoft 365 for the first time, and you say, make me a presentation for this meeting I have on Friday, and it's about this customer, and I'm going to sit back and think like, yeah, it's going to be incredible. It's not. It's crap, probably, right? Because it doesn't know where to find these things. You need context and metadata around your documents. Otherwise, it's just not going to give you back much. And so what we need to look at is not just chunking and not just vectorization, but something hybrid where we can think about how I am interacting with my human language to that chunking to make that configuration more navigable for your LLM. And we can do this a couple different ways. A scoring profile is one of them. So we can train Azure AI Search to say, like, look, the way I asked that one question, that was good. The way I asked it another way, not so much. So, like, let's keep going back to what made that first way go, and let's learn that way. So with that, though, let's talk a little bit more about indexing, Matt.
Yeah, so indexes are designed to be non-relational and very fast. And this first part, non-relational, is very, this is the key part. So as Alex was talking about with structured data, a lot of times your data is going to be not only structured, but it's going to be relational. So think of an expense report. I have an expense report line, and then I've got line items underneath that. There's a relationship that's set up between those. So that doesn't happen when you're in an index. The index is designed to be flat and to query back very, very fast. So when we get and to Alex's point earlier, if you want to start having this relationship described and have it queried in a fast way that the LLM understands, now we get into something called graph databases, and those are features where that relationship is described in language rather than as a number, which or GUID or some other type of identifier. Because for the most part, the LLM doesn't understand what those identifiers are. It sees it as a series of text, or it sees it as an integer, a number, or something like that. The graph description, though, it understands and can follow. So that's that. Again, we're starting to get beyond what we're talking about here, but that's one way you make your relational more indexable and more accessible to your AI searches. Index engines that are purpose built, and I stress that, purpose built for AI, like Azure AI Search, have very specific features to increase your large language model performance. Your data query is abstracted from your database. So there is a copy, if you will, of that data in that index. So when you're making a query, you're not querying your database, you're querying the index. So the database runs off happily over here, where I can make different styles and different queries to that index to return my data. Now, this is super important when you talk about, when you get into data structure and you talk about, okay, well, what columns are indexed? So if I throw a query against a large database that doesn't have an indexed column, that performance is going to be poor. Not only is that performance going to be poor, but my DBAs are going to get really upset at me after a while if I keep banging on it. The index allows us to choose our columns in whatever fashion, any way we want, to be able to return data and make it fast, because all those columns are indexed because it quite literally is an index. And this also allows us for different configurations.
Sorry.
Go back.
Sorry.
Too fast, Alex.
It's going. Keep going.
See it. There it is. So another thing that you get into when you really start to go down the rabbit hole of AI and generative AI and how we use this kind of stuff, you start to understand, you start to read things about fusion RAG and fusion searching and things like that. And all that means is that you've got different search techniques. Maybe I'm doing a keyword, maybe I'm doing a vector, maybe I'm doing semantic search, and you fuse the results together and get the best result set. The ones that are built specifically for AI, like Azure AI Search, come with this fusion algorithm right out of the box. So you don't have to build that. Now, I have attempted to build fusion searches by myself in code. Anybody else? Anybody else try this in code? Right? Good. Don't. Right? It sucks. It's hard. Okay. AI Search does it out of the box. That's something that really helps. All right, Alex, go ahead next. So as we get into this, what other things does AI Search and other purpose-built style indexes give right out of the box? So built for its high performance at any scale. Of course, you have to pay for that scale. Microsoft doesn't do things for free ever. But our retriever in a RAG model has to have some sort of retrieval system. Of course, you got to get the data back. You have to have some sort of re-ranking. So when I search keyword and then I do a vector search, I need to re-rank those searches based upon whatever relevance they have with the various types of searches that I have done. We have to have some sort of chunking formula. All right. The LLM can't take 30 megabytes worth of information right at one go. It has to be broken up, and you don't want to do that either. So when I take a look at a document, my documents are broken up into headers and different sections and things like that. I want to be able to take that section and comment on that, discover on that. I don't want the whole entire page or the whole entire document involved in that. So that's what chunking gives us. We need to have some sort of embedding structure. And the embedding is I need to take those words and turn them into some sort of number format vector that the LLM can then search on and understand to make relationships based on the similarity between the words rather than just a keyword search. Again, Azure AI Search out of the box. Soon as you're ready to go, it's ready to go for you. So when are you going to use indexes over databases? Again, big relational data sets. The larger the data set, the more context it's going to need. If you have lots of complex documents, and these are, so say I've got a manual that I'm in a manufacturing company and we're rubber chickens, because that's our example later on. We're making rubber chickens, and I've got a 400-page manual of stuff, right? That's a big document. All right, we're going to use an index to crack that up. And then if I want a really complex chunking strategy, so say I don't want things based on their page. I want to base things on what they mean semantically. That is a complex chunking strategy, and I'm going to use things like the LLM. I'm going to use document intelligence. I'm going to use Azure AI Search to break those things up as semantic ideas rather than just chunks of pages. Now, I do want to stress here, when we talk about large data sets, you do have to kind of recognize what is where's my truth center database, and then what is used for querying. So if I have a data warehouse or something like that that's out there that's specifically designed for querying for me to run my reports against, that's now we're good. We're getting in a relational set that we can go ahead and hit. We're not going to mess with the truth center. We can get our data out without really causing anybody any pain and consternation. And we'll go through that in our demo. How do we get that information? How do we make queries that are based upon the user question? Now we'll go through some demos. All right, everybody ready for demos? Yay, demos!
So Matt, as you're pulling this up, Scott brings up a good point here. He says, this opens up a new path of data strategy and Power Platform, which, well, let me rephrase that. So this seems to open up a new path in data strategy. There needs to be a path for strategy around files and Copilot if we want to go down this path. Is that correct?
Yes. And we'll get into that here in just a second. But yes, there has to be a strategy for that. And it's going to get even worse because Microsoft just released SharePoint agents, which allows you to create a Copilot based upon your document library. And again, if your documents aren't prepared for the LLM, you're not going to get the best kind of responses that you want out of that. So that definitely, you do need a document strategy. And where am I getting stuff and how am I putting stuff in is all going to be a consideration of use of Copilot. And one of the things that I joke with some of my Microsoft friends is we're going to bring about a revolution, not in AI, but in document writing. So you're going to think twice if you're creating a document that's 20 pages long, 30 pages long. That isn't going to compress into a SharePoint agent very well, or into a straight Copilot agent very well. So maybe our documents are going to get shorter, and we'll just have a lot more of them. Maybe, I don't know. We'll see how technology goes here in the near future. But you're right about that, Scott. So we're going to create we're going to have an index here, and this is what I am indexing. These are simple transcript files that we have based upon, they're just text files, right? And I've got them in a blob storage in Azure. So when I take a look at, the first thing I want to do is I want to I create an index, and I'm going to have a series of columns with that. So I have some fields with this. So I'm going to go into my index. Here's my index, and here are the fields that I'm creating. So first of all, I have a chunk ID, and the chunk ID is going to be the identifier for the piece of information that I want. So we're chunking these documents out. Parent ID means we want to keep everything together, so all the chunks have a parent ID from the first chunk. Then we have the actual text here in the chunk. I've got a title, and then I have the vector. So I vectorize what's coming in this chunk into this area, right? And this is a single collection. The dimensions on this, I'm using the default here. You can mess with dimensions. Now, I'm not going to get into dimensions and that kind of depth of index design, but that is something you can take a look at later on. Now I have the context. So think right now, I don't have, this is a demo, right? So there aren't a lot of transcripts, but think if I have a company that's doing a lot of transcripts. They're taking a lot of calls, and all these calls are recorded. So, if I've got, maybe one person can take 1,000 calls over the period of a week. And I've got 10 people on the team. You can see how this multiplies out. I would have millions of these in here. So I need context. in order to determine, okay, what's this about, and how can I get to it? All right. So here I have my representative's first name, representative's last name is captured. The call queue, is it customer service? Is it sales? The sales result, did something come of this? I have my manager. Maybe this is connected up into Entra ID where I'm pulling my manager's name. So I've got manager's first name, last name, and then I have the date. So this date time is probably going to be one of the more important pieces of context that you bring here, because if I'm looking for pink rubber chickens, I probably sell a lot of pink rubber chickens. So when am I selling that? What time did that call occur? So this one is going to be important. So all these things help us filter down. You see this column here that's filterable, right? So when I do a regular search here, I'm going to go in Search and Explore, and I'm just going to search. We're just going to search, and it pulls up all this stuff. This is what the vector looks like, right? It's just a bunch of numbers that goes on forever, right? So let's change our view here a little bit. Let's turn off our vector search real quick. So you can see here, this is the stuff that we get into, right? This is the search for term. Now, maybe I don't want all this stuff. I want something that's going to be based on, I want my person to be Alex, and I want to make sure that I'm getting, just the sales results from him. So in my search, I can change this, and I'm going to add something that's interesting. I'm going to come here, and I'm going to call it a filter. Now, my filter is an OData filter that I can go ahead and paste in here. Now, if you haven't used Windows V, that's been around for a while, you need to, because now I've got everything here and I can just Windows V it all through. So my filter here is going to be based upon my friend Alex, and I want the sales result equal to true. So I'll search this, and now I've got my response here, and you can see here my response is just 12 documents. All right. Now a document is defined as the chunks. So I don't have 12 individual pieces, 12 individual text files that are in here. I have 12 documents. So 12 entries, 12 rows in the index that are responded. Now, how do I get those chunks? How do I get those pieces? How I get those pieces is I'm going to use something called a skill set. And the skill set happens when I'm actually indexing my information. So I'll go into my skill set here, and I'll show you how this is chunked. The first one you see here is a text split skill set, and text means I am getting the index sees the document, the actual piece of paper that I'm feeding it, as text. So you can see here I'm going to split it up, and it's going to be based here. My mode is going to be pages. Now, it doesn't understand what a page is. It doesn't know page 1, page 2, page 3, page 4 like we do, or like our document programs serve up to us. What we're saying here is that a maximum page length is based on characters, 2,000 characters. And we're saying we have an overlap of 500 because we don't want to cut a sentence in half. So we're saying, give or take 500 characters, give us 2,000, and that's a page. Does that make sense to everybody? This is the chunk. So it's going to look 2,000 characters, next one, next one, next one. Okay? Couple of thumbs. All right, good.
Good.
From here, what we're going to do is I'm going to give it so this now feeds into the embedding skill. The embedding skill is I'm going to go out to my LLM, and I have an embedding model that I've deployed. And the embedding model, you can see here's my LLM, right? Here's my embedding model. And I'm going to take that text from the chunk. I'm going to feed it to the LLM, and the response back is going to be all those numbers that you saw. That I save into my index. Okay? I go to the LLM that I'm going to use, the embedding model that I'm going to use to search later on is the same embedding model that I use to encode in the beginning. Okay? It has to be the same, otherwise your vector is going to be off. All right? And we'll see this later on in another demo. The last thing I do is I use the in the title, I take the document title here, and that's just the file name in this particular case, and it saves it now into, you can see these are the field names. Okay, so we have a chunking model, we have an embedding model, and we have a retrieval model. So we've got everything that we need. Now, one last thing that I didn't show you when we were dealing with this index is that re-ranker, that hybrid search. So if we go in here and we take a look at this in that JSON mode, and I'm sorry, I can't make this any bigger. You see here, I've got my vector query. This is all I need to do to create a Fusion search within Azure AI Search. There's my vector query, and then I'm giving a query type semantic, and that's it. Because I've named two different types of queries within this particular search, it's going to do a fused hybrid semantic vectorized search. Now, because I have a scoring profile put onto this, it's going to re-rank this based upon the weighted fields that I've got here. So I'm saying that anything that the representative's first name and last name are weighted 4 times higher than anything else. Okay? All this goes together so that I can get a good return of my data. All right, back to you, Alex.
Okay, as I'm pulling this back up, Christopher asked a question just before the demo about document preparation. Would you consider that the tagging part of this, Matt?
So document preparation, it depends on where you're going to save. What's my ultimate model of returning? So it's not going to be necessarily tagging, because you're going to be breaking it up into the pieces. So that automatic thing that I just showed you with the chunking, you're going to have to do that manually if you're using just like a SharePoint agent or something like that. If I'm indexing through AI search, I let the machine do it. And so that's kind of the metadata that you see on top of that context, the date, the representative's name, and that kind of thing. That is going to be part of that tagging. That's definitely part of the tagging process. And you can, in SharePoint, there is a way that you can take what's in SharePoint, the SharePoint metadata, and put it into Azure AI Search. I hope that answered your question.
You see my screen, Matt? Good to go?
Yep, good to go. All right, so we're going to get into now the ways that we integrate these things. So the way that you're going to use Azure OpenAI in Copilot Studio is you're going to have a series of prompts. And the prompt is going to be a system prompt. The system prompt is based upon what I use to actually train my AI. That's the one that says, AI, you are this, and you're going to respond in this way. I then have generative answers. The answers are going to be tied. So I'm sorry, I got confused. Excuse me for just a second. The way I use OpenAI in Copilot Studio is I have prompts, and a prompt is a way that I can use the LLM outside of actually deploying something in Azure. So I have a way that I can send a prompt to with data to the LLM to get a response back, and I'll show you how to use that here in just a second. The next way is I'm going to use generative answers, and generative answers are a way that I can connect up into my Azure AI system with my search method to be able to take information that the Copilot is giving me and then process it in Azure OpenAI and then get a response back. The thing about this is that Copilot is handling that response. Copilot is designed to use multiple different data sources in its response. So you get some automatic truncation and automatic summarization that goes in with this. You don't get the raw response back from Azure OpenAI. So finally, I have a direct HTTP call. And this is my control. I say exactly what goes over to the LLM and what comes back. Okay, that's the way I do it. Now we're going to talk about actual prompts, the speaking prompts, not prompts like in the other sense. So again, I have system prompts, and this is what I tell the LLM to do. User prompts are what the user has actually put in. Augmentation prompts are where for the most part, the users ask silly questions. and I have to do something to help that user get back the response they want. And a lot of times I'm going to use LLM in order to rewrite their prompt so that it's augmented and I can get more information back the way that the user is expecting, but not necessarily can ask for. Regardless of what data is in your data index, you have to ask for something, right? So if I'm not asking, I have to be specific. I can't just say, summarize the conversations. It's not going to know what conversations I'm talking about. I have to ask for something. Okay, finally, more demos. All right, let's get into what this actually looks like. All right, so here's our index, and this is our index that we're going to be bouncing our stuff against. All right, so I'm going to go into Copilot Studio and my bot. So again, we are a company that sells rubber chickens because rubber chickens are funny and I like them.
We're really busy this time of year.
Yes, very, very relevant. Everybody wants to buy a rubber chicken for their loved one for a stocking stuffer, right? So what I have is a series of transcripts that are based upon calls that are made, sales calls or customer service calls that are made from our system. Okay. Now the first thing I'm going to do is I'm going to connect into my index, my Azure AI index, by using a generative response. So one thing about this particular product right off the bat is that I am using, let's go into settings, and I am using generative here. This is chaining. So essentially what that means is I am handing control of my bot over to the LLM. The user is going to put in their information, and then based upon the descriptions I have in my topics or in my knowledge, the LLM will choose which one I go into. Okay? That's super important, because when I come into here, topics, and we're going to go into our generative answers, I have a description. And if I'm using generative answers, I'm using generative as my source here. Dynamic chaining is based upon this guy right here. So it's going to say this topic answers questions about sales and customer service transcripts. So if I ask for something like that, it's going to find this particular topic and run it. It's important that there are no phrases. I have not described to this topic what kind of things it should hit on. It's going to use the LLM to make that interpretation for me. Okay? If you want to know about dynamic chaining and how that works, that's another webinar. My tens of fans, come back to me. Like and follow. All right. See, that usually gets a big laugh if we're in person. So anyway,
it does not get a big laugh. It does not.
Alex laughed. See, I got a couple reactions. All right, so let's go into our generative answers. And this is, if you want to find this is going to be in the advanced section right here under generative answers. And what I've got here is I'm going to edit my data sources, and this is where I can specify the actual knowledge or data that my Copilot is going to be responding on. All right. So here I have turned off only selected data sources because I want it to use this, and I've also turned off it can't use the internet to make a response. I want it only on the stuff that I'm giving it. Here in classic data, you see that's grayed out right here because I have that in the overview section. That's where I have this. So this is it's using the best how to respond to events, but use its own general knowledge is disabled. Okay, so it's not going out to the internet and using its own trained information to answer this. It's going to answer it based upon the data that I give it. All right. Let's go back here. All right, so in here, I'm going to go into this classic data, and I'll show you how this is set up. So the first thing I do is, you'll see there's no websites, there's no SharePoint. I have a connector. And the connector, honestly, it's super easy. I'm not going to show you how to build it because it's just you need the endpoint and you need the key, and that's it. and then it creates a connector for you. If your key's wrong, your connector won't connect and that won't work. But the big part here is this connection properties. This is my configuration. So the first thing I do is I give it a deployment name. And so what is this? When I am in Azure OpenAI, and this is AI Studio, I am going to create a deployment. This is the LLM model that I'm using. In this case, my deployment here is GPT-4o. And you'll see if I go down here to deployments, I have two deployments. One is going to be the generative model. The other is the embedding model. Okay, so this is the vectorizer that we just talked about in index. And this is the thing this is ChatGPT version 4o. All right, so I'm configuring that. I'm going there. And now I'm giving it the API version. The API version is the version that I want I want to use to both talk and respond. This has to be something that is compatible with Copilot Studio. Now this is really nice because I've got a drop list here and it'll tell me which ones it accepts. Okay, so I'm using the latest one here. I'm giving how many tokens I have in a response. So how large can my response be? This is based on how much I want to pay. All right, the more tokens is a configuration on your LLM. It's also based on how much I can pay. How much, the more tokens, the more expensive it is. Temperature this is going to be how this gets into the transformer a little bit, the T in GPT, but this is how creative it can be in its responses. And I have it not very creative right now. And then I have a stop sequence. We really don't have to, with version 4 and above, you really don't need, there's not a lot of repeating that goes on. In previous versions, you had a lot of repeating, and that's what that stop sequence is for. You really don't need this too much anymore. Now I'm going to configure in my data sources. So now here's the Chicken AI. That's my Azure. That's my index, right? And then I have the fields that I'm returning. I'm just using the basic stuff. I'm not replying to any of this because I have a title. This is my title field. I don't have a URL to bounce back. That's where my my references will go. And then I have the file name is going to be title. All right. Finally, I have my embedding stuff. So what kind of search do I want to do? I can do a hybrid vectorized search inside of Copilot Studio. This is new with the latest release. So I'm giving it my embedding name. So this is where you go to embed, and then this is my semantic configuration inside of my index. And then finally, I have the system message. So this is the prompt that I'm telling it. Right now, I'm saying you're an AI assistant that helps people with information on transcripts. Okay, that's what I'm telling it to do. Other stuff is how many top end documents. This is important because this is how many, I'm limiting how many responses from the index I can get. So this is important. If I ask it things like, how many sales did Alex do in a certain amount of time? If I limit that to only 5 documents, it's going to tell me 5, right? So you can hamstring yourself if you don't have enough. But if you have too many, it'll blow up because you get too much information back. So you got to this is kind of a balancing act that you play. Okay, so this is what I've done. So the first thing I'm just going to ask it is a very simple question here. How many sales calls did Alex take that ended in a sale? So we're going to go ahead and send that over to our LLM. And you can see here, I've got it set up to track. And so what this means is I'm coming in here and it's saying that, all right, I have selected the generative answers topic for you, and I'm running it through. And you can see here, Alex had the following sales that ended. So standard size multicolor rubber chicken with a squeaker, bulk order of 500 rubber chickens for top circus, and medium for a collar's puppy, right? So I've got good information back. So what if I want to know something different? So let's go ahead and let's ask it, okay, let's summarize this. So you can see here that I'm gonna get a little bit of a problem. It doesn't know what I'm talking about. And the reason it doesn't know what I'm talking about is because it's already returned this stuff and it doesn't understand where I go next. And so for that, I'm gonna need to use the LLM model, the bigger model, all right? So let's go ahead and clear this, and we're going to go into topics again, and let's play with let's get granular with this kind of stuff. So I'm going to turn off my generative answers, and I'm going to go into my transcript search topic. And sometimes this can take a second. Hopefully not this time because it's a live demo. Talk amongst yourselves. There we go. I guess you can't talk amongst yourselves. You're all kind of here, right? All right. So we're going to go into our transcript search. This one, you can see here, the first thing is it's triggered the same way. But as I get into this, so I'm saving the original ask. I'm taking what the user has asked in a prompt, and I'm going to save that into a variable so I can use it later. The next thing I'm going to do is I'm sending it to a prompt. And I'm asking a question here. I want an OData filter. And what that prompt looks like is this. I stopped sharing. What that prompt looks like is this. So I have something where I am describing the table to the LLM. And again, I don't need to deploy something in Azure in order to get this. This comes from Power Platform. I've described my table and I've said, okay, give me an OData filter based upon the intent of the user's question and the fields above. Give me an OData filter. So I've got a little test thing in here where you can see here how many calls did Matt Meyer's team take last month. If I click test prompt, it'll send that to the LLM and it gives me an OData filter. So in this way, I am very dynamic. I don't care what columns this person is asking about. I can create a filter based upon it. I don't need pre-made filters. I can build it right now. This then is passed into my LLM. So the next thing I do is I get that information, and now I go and I do another prompt. I'm going to take this user, and I'm going to augment the user prompt. So essentially what I'm doing here is the same kind of thing. I'm telling it, these are the fields that I have to deal with. And the index can be filtered based on an OData, and I give it my OData filter. And then I say, understand the intent, create a user prompt that will return the best results for the user. So I'm taking what the user has given me, and I'm running it through the LLM, and I'm saying, make this better. Now I'm going to use that as the user prompt. So now I have an augmented prompt. So what have I done? I've created an OData filter based upon the user's natural language query. Next, I have created an augmented prompt based upon my query, what I have in my, my index, and the user's prompt. From there, I make an HTTP call. So this is a direct HTTP call to my LLM. What does this look like? A bunch of gobbledygook, right? This is the JSON payload that I need to send. And you can see here it's very similar. Here's my data source. There's my query type. I'm doing a hybrid query type. I give it role information. Role information is the system prompt, right? And then here I'm giving it documents, my strictness, all the stuff that we saw before. But I'm also adding my filter, okay, that comes from my prompt response. From there, I'm also adding my user prompt, so the prompt that I just got, and then I'm going to get back a response. So now let's go ahead and put in that same question. So summarize the sales call that ended in a sale. And what we're going to do is I'm going to turn this off for a second, right? And we're going to go to our topics again, and we're going to go into transcript search, and we're going to take a look at the variables as they're populated. So this is one way you debug your Copilot. So we're going to hit this, and this will go ahead. You'll see as it's selected, you'll see these check marks of what has been hit. So you can see here I have my OData output already. So we'll go down and what did it do for my my OData prompt? All right, so this is what it's coming back for the query. I'm doing this. So Alex Andros is the first name and last name. I'm going to a sales queue called sales, and my sales result is equal to true. I filter my results based on that, and then I send it my prompt. What's my prompt? My prompt is going to be, this is the new user prompt, okay? It's going to be summarize the content sales calls handled by blah, blah, blah. Not too different what I had before. And this is what I get. I get a nice result of the ones that sales. Now you'll notice that there are more than the other ones showed up because I'm able to very specifically filter on the examples that it gave me. So I have 6 documents. Alex made 6 sales, and these are those, and I have a response on that. So in this way, what I've done is I'm using that Azure AI search. I filter it. I'm getting an augmented prompt, and I'm sending all that back to our LLM to get a response back. Okay? And we're running out of time, so I'll cut the fun stuff. Go ahead, Alex. There are other things you can do with this. So one other thing I did want to show real quick was, let's clear this because we're doing a new conversation, is that I can ask it interesting things about my questions. So I can ask it such things as, what conversations did Alex have that had military context, right? Or sentiment analysis. So someone bought a pink rubber chicken. What was the sentiment occurred here? So if you look at this, what is going to be my filter? My filter is going to be a sales call based upon a rubber chicken, a pink rubber chicken that has Alex. Well, I don't have anything about pink rubber chickens in my context, in my filter. So what is that filter going to do? This is where hallucination becomes a real problem. But it's also why I described my table, I described my index in my prompt so that it won't make a filter based upon things that don't exist. And you can see here the overall sentiment of the customer during the sales call where a pink rubber chicken was purchased was very positive and flirtatious. Alex, what are you doing in your rubber chicken calls?
It's end of year. You got to do what you got to do sometimes to close a sale.
I guess. So the customer expressed admiration for Alex's efficiency and charm, complimenting him, showing delight in the product and the service provided, right? So that's the sentiment of that particular call. That I can do inside the LLM. The LLM made that choice. This just comes from the information that it gave me. Okay? I know we're running out of time. We'll go ahead and stop there. So closing out here, Copilot Studio is actually quite an amazing front end for your generative AI sources. You can go out and hit APIs. You can hit the OpenAI system to bring back full cited responses from your index, and you don't have to code it. And that really makes things easy for you if you're making a generative bot. You can also take it with the power of the Power Platform and extend upon that to be able to do actions. I can run flows. I can run other things based upon this. It's easy to connect with data. You get direct integration with Entra ID. I can limit my bot to individual people, so that's one thing that we can do as well. You have easily deployment in Teams, SharePoint, Power Platform, and there is a streaming limitation. So if you're using like Copilot in Microsoft Copilot, you'll see it kind of load its information in chunks. You can't do that with your responses, so you do have to set. There is a bit flip in the payload of sending it to Azure OpenAI where streaming equals false. That can be a performance limitation, so you do have to be aware that streaming right now in this release not available.
So in closing, and I've been hitting some of the questions, Matt. If you take a look, Uma and Monica have a couple good ones that
okay.
I'll allow you to get to. But if you want to look at that, well, I just close you because I know we're at time here. And look, thank you for sticking with us today. But in the end, give us a call. There are some things that Matt alluded to that we couldn't get to that we can talk to you about. But if you're looking at starting a POC, a pretty robust pilot, or you want to get into full production, we can help out, right? Reach out to Matt or myself. And our suggestion, though, is to find a meaningful use case, right? Get started with something that isn't necessarily a pet project that might be a bot to understand where the parking spaces are available in your building. But what's something that can move the needle and show some results, right? Show your colleagues, show your board, show your bosses that, look, this is actually working because we're doing it and we're helping customers. And with some pretty robust type of situations, right? Whether it's a product catalog where you need to find hundreds and hundreds of thousands of SKUs to search against, like that, like we built it. A lot of people are looking at us, given Matt's example, for kind of sales enablement bots, and that can be account management if you're in the financial services and you want to get kind of up-to-date information on your portfolio or what you're lending and kind of what the market's looking like. We can build that sales assistant bots to talk about, how best to input RFPs based off of past projects that you've won, things like this. But your use case is likely going to be different, and we just ask that you give us a call, and we can help you out in kind of talking that through and how best to approach it. So that's it. And if you're hanging with us this long, we really, really appreciate it. If you have more questions, please put them in the field, and I will look to remove I can't talk right now. The mics and the chats, we'll open all that up, and we'll hang out here for the next couple minutes if you want to ask us some questions. This is our contact information. Also, hit us up on LinkedIn to hit us up. I can't believe I said that. I'm a YouTube person now, I guess. But we post videos like this content on YouTube as well. All right, Matt, if you can start getting the questions, I'll remove the permissions here.
So Monica has a question here. If I understand correctly, deploying the OpenAI model to Copilot Studio as an agent is required to configure the Copilot to use the model for generating responses. That is correct, yes. I noticed a warning and wanted clarification on the statement. The data may be stored or processed outside your tenant's geographic region or compliance boundaries. Does this mean the data could be exposed outside the tenant? No. All right. You are creating everything within your tenant. What Copilot is yelling at you is that you can connect to any data source that you have a key to. So if I have a key to a data source that is in your tenant, right? Then I can grab that information and maybe outside my geographical region. Another example is that if I'm using everything within my tenant, and there's a couple different ways that you can configure this so that you're using either a key or you can use an identity or something like that. How do I ensure that it just stays within my stuff? The geographic region. Basically, what it means is that I have to deploy my OpenAI in a geographic region. So say I deploy that in East US, but my Copilot environment, the environment that I'm creating Copilot, is in the UK. So I can connect the two, but it's going to be outside that geographical region. So it's still in your tenant, still inside your area, but it may cross that geographical boundary. Okay, that is something that it's talking about as well. So how is security ensured? Everything is secure within your own tenant with Entra ID and your the various API keys that you're given, if that's how you choose to secure it. Now, one thing that is important is that there is no granular security within the index. So if I'm pulling information from a database or wherever documents into that index, I have to ensure that the people that are connecting to my Copilot, connecting into that Azure OpenAI, have the right security. That's easily done inside of Copilot with the way that you share it, so that you can keep up and I think somebody else had prompts for oversharing and things like that. That is controlled by your Power Platform and how you have your governance strategy set up. Now, if you need help with setting up an environment strategy or a sharing strategy, we can talk to you about that. But it's based upon, I have this environment, these people are given rights to this environment, these people are given rights to this particular prompt, or this Copilot, and they can use it. Okay, I hope that answers your questions. Chris asks, similar to the Azure services, use of connectors defined as premium, incur cost per transaction. The Azure services are pay as you go. So yes, that incurs regular cost. The index is going to be the most expensive part of that. So they are also considered premium. I'm sorry.
I'm sorry. I cut you off. I was just going to say, I've been chatting with Chris. The connectors are tied to the Power Platform though, and within Power Automate.
Yeah. So if you're using Power Automate for that, then yes, that's going to cost you. If you're using Copilot Studio, there's a different licensing model entirely. Okay, so I hope that Microsoft makes it just as muddy as possible.
Matt James has a question. When you create a vector index through Azure AI Studio and not through Azure AI Search, is it possible to use the vector index in Copilot Studio?
Yeah. So if you're doing it, so if I've created a vector search inside of Azure AI Studio, you have in fact created something inside Azure AI Search. That's its index. That's exactly where it's pointing. Okay. Does that answer your question? Make sure you put yourself off mute and answer there, if I'm understanding the question correctly.
Yeah, I just had a question. Like when you were setting all the search config stuff in Copilot
Yeah.
Studio, it asked for that semantic
Yeah.
part. I can't find that in the AI Studio section,
Okay.
so I didn't know what to put
All
there.
right.
Yeah.
So there is the semantic search is something that is a premium connector. You need a different pricing tier. If you're using basic or free, you don't have the advantage of semantic search, so it won't be there. So as long as you go into the next tier, the first standard tier, you can create a semantic profile that you can use.
Matt, Steve just put something in here. Do you have any recommendations on how to set up Copilot access to Azure AI resources using private endpoints and deployed within a virtual network?
Yeah, you can do it. Do I have any recommendations? That is a really, really, really long conversation. So let's talk about that later. But absolutely, you can create private endpoints. You will have to whitelist what comes from Azure You will have to whitelist what I really want to see the transcript. Does the blah 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 blips come out? That's going to be interesting. You will have to whitelist Copilot Studio and the Power Platform, and there's a group of IPs and other things that you'll need to whitelist. But absolutely, you can create a private endpoint for that, for sure.
Thanks.
Using a virtual networks. Now you're getting a little wonky because your virtual networks are going to have to include Azure networks so that you can use the Power Platform within that virtual network.
Okay. Yeah. Thanks. Yeah.
Yep.
That makes
Really
sense.
long, really short answer to a very complex question.
Yes.
If you want, we can talk about it more later. But that's it's there's a bunch of configuration that goes into that.
Okay.
Will the recording be available after this event? You betcha.
Yep. Got that. For folks who are sticking around, Steve and James, hopefully we answered your questions here. If you want to, I've removed. You guys can come off mute, and we'll hang if there's any other questions.
I had a question. If you know of any like literature or documentation on how to decipher like quotas, prompts, tokens, limits, because every time I'm like creating a deployment model, I'm seeming to hit some sort of quota.
Yeah.
Let
me show you that. That's a gotcha. And you know what? I'm gonna make I'll make another video on this later on. So like and subscribe. But if you go into your into Azure AI, so let's go into our thing here, and we're gonna go into OpenAI here. And I need to go into my quotas. All right, is it here? Now I'm forgetting. All right, so here's my quotas, right? And if I go into my quotas, I have to give myself, you're given, when you sign up with the standard tier, you're given a certain amount. And the first thing Microsoft does is drop those all the way back. It makes it really, really difficult to use because you type something in and it says, you're over a quota, or you need to wait 30 seconds or something like that. So you need to go into here, and as soon as it loads, hopefully it'll load. You get your subscription and go. And go. All right, so this has taken much longer than I expected. Here we go. The first thing I do is I'm going to filter this. Not by that. I'm going to go into my Azure AI provisioned. No, I'm not. What am I looking for here, Alex? So you see a whole bunch of these. And there used to be a way where I can just do the ones that I have. All right, I unchecked it. Here, show all quota. I turned that off, and it's only going to be the ones that I've deployed. All right, so inside global standard, inside GPT-4, East US, this is the area that I have. You can see it's got my quota allocation. So I'm going to go into here. This is the deployment allocation here, right? And I can edit what this is going to be. All right. And I just screwed myself here. Hold on. Global standard, GPT-4, East US, and then I scroll to the right. I've got an edit button right here. This is where I do my capacity tokens per minute. Okay, that's going to help you with that quota. I can put this out to whatever I do. I usually put it here towards the end because it comes standard with it. It's not going to cost me any different.
Right.
It does cost me if I hit it a lot, but this is how you do those capacity tokens.
Okay.
Okay.
Thank you. Yep.
If you want more than that, you got to pay, and you got to contact Microsoft directly.
Okay.
Now remember, and this kind of gets developer-y. This is a stateless service, and you can have multiple deployments. So if I have a lot and I've got a lot of requests that are coming in, and I have to think about persistence a little bit. But the way that your payload contains the former messages that you had, so you can send this to multiple different deployments. If you really have something that's very, very, very complex, you can kind of round robin where these go, and you're just containing that in your JSON payload, your message context, your conversation context.
Francisco, I just tried to give a best shot at your question about use cases. Off the top of my head, a use case with a spend limit is tough for me just to calculate without knowing a lot more details of what you're trying to accomplish. Is it possible? For sure, we can talk to you about it, but there's a lot of variables at play, especially just, Matt, correct me if I'm wrong here, but it's all about kind of the document size. Yeah, you got me. But that's really it. There's so many different options really, but there's a lot of variables here that make
what's the question on spend limit? I'm sorry.
So $200 a month. What can we do at $200 a month?
So that is going to be based. Yes, yeah. So what Alex said, it's a lot of it is going to be based upon the tier that I've selected. Your standard tier, you're going to need at least $300 a month. I run my stuff on MSDN, $150 a month things, right? And I actually ran out this last month because I was using it for this, trying to get ready, and had to move it to another subscription. So you will hit those pretty quick. All right, I have a hard stop. I got to go pick up my daughter. I thank you all for coming. If you have other questions, you can connect to me directly, either on LinkedIn or just through email address. We will be sending out this deck, so you can have it. All right, guys, I appreciate it. Thank you very much.
Thanks, Matt. I am putting our contact info in here. Find us on LinkedIn. Email us if there's anything that we can help you out with. We will send a copy of this presentation. We will send a copy of this deck as well. Thanks, everyone. Have a great day. Talk to you soon.
Thanks.